Hi, I'm Spencer Krause. I've been building robots for over 20 years. In that time, I've seen a lot of interesting things, and I've heard a lot of interesting stories. Collaborative with Spencer Krause is a place where my colleagues and I can relax, have a drink, and talk about some of the crazier things we've seen at work and some of the experiences we've had that have gotten us to where we are today. Subscribe today to join the collaboration. Welcome to the Collaborative Podcast. I'm your host, Spencer Krause. Our guest today is Alex Foessel. Alex is a managing partner at Balanced Engineering. Alex, welcome to the pod.
Oh, thank you. Thank you for having me. I am delighted to be here.
I appreciate you coming on. We've been talking about this for a while, and just happy to have you.
Well, I don't know whether it's your schedule or my schedule that got in the way, but I'm delighted to be here, and of course, I enjoyed dinner prior to this event.
Yeah, pleasure getting together, and we'll do it again soon.
Oh, hopefully.
So I guess there's a bunch of things I'd like to jump in. So you grew up as like a rancher in Chile, right?
Yeah, exactly. I grew up in Patagonia. That's where we have, even today, a ranch with my siblings and my mom. Cool. And we produce around 800 to 900 heads of really, really good Angus beef.
Nice.
Cows. And of course, that takes a lot of work.
Yeah, I'd imagine. So there was an interesting anecdote that you'd mentioned. You were one of Red Whitaker's students at Carnegie Mellon.
Yeah.
And he has like a small farm, right, is my understanding.
Right. I think it's close to the exit in Somerset exit of the Turnpike.
Nice.
And it's interesting because once Red and I got to know each other, I said, Red, I'd love to visit your ranch. And of course, he invited me one of these weekends. And of course, the rest of the time I was a grad student, of course, trying to go through coursework. But I had a chance to actually spend a couple of weekends working, more than a couple of weekends, working. And I found myself fixing tractors overnight, right? And actually, interestingly enough, we fast forward, we're going to find John Deere as part of the story. But that actually was the first time ever I ran into a John Deere tractor at Red's farm.
That's awesome. And you ended up working for John Deere for decades after that, for people listening.
Yep, exactly. So it was, because in South America, at least at the time I grew up, other brands were predominant, like, for example, Massey Ferguson or Ford even. But John Deere, or maybe it was too expensive or for whatever reason, but it was not part of our fleet.
Yeah. That's wild.
Yeah, I know.
Yeah. I think I spent a lot of time working on cars with Chuck Whitaker in the Field Robotics Center, Red's brother.
Yes. Well, even though the two brothers are very different, they're both to be loved independently. Yes.
Yeah, absolutely. I don't know Red as well, but he seems like a solid guy. He's touched a lot of people. And when you mentioned some of the other people that you came up with, I'm like, I know a lot of those names.
Mm-hmm.
So.
Well, I think that there's the School of Computer Science at Carnegie Mellon, and then within the Robotics Institute, but the Field Robotics Center.
It's special.
That was special, and of course, Red was leading that. And I feel that the type of work that was this intersection between bringing technology together into something that is functioning, but actually putting that out in the field to actually do something. I know not too many other research institutions or organizations that put so much stress into actually, let's go test things out there.
Absolutely. Now, I had a mentor, I still have a mentor that I've been working with pretty much since right after I graduated from my master's degree. And he maybe has like a little bit of a bone to pick with academics. And so he's like, these academics don't know anything and they never made a thing. And I'm like, the Field Robotics Center is different. Like, we built plenty of stuff. You know?
Yes, exactly. And that in turn, led to the National Robotics Engineering Consortium, where I would say that that's the next step towards taking technology and not only showing that it works in the field, but taking the next step to actually make it more robust so that it doesn't do something once, but over and over and over.
Yeah, that's awesome. I'm NREC, actually, I went through there as a kid. So my dad's cousin was Lee Weiss. I don't know if you ever knew him, but he
Name sounds familiar, but I can't picture a face though.
Yeah, he had a corner office in Noel Simon Hall, like down the hall from John Dolan and Hagen Schempf,
Yep.
and He took me on a tour of NREC when I was very, very young, and I saw, I think it was an ABB arm because it was orange, that was doing some light machining work on a panel and then painting it. And I just thought it was the most awesome thing. And from then on, I was like, that's what I want to do. You know?
Yep. So part of my PhD, actually, the last 2 or 3 years were focused in working at the NREC in one of their projects. All about perception, radar, and trying to make sense of the world, even when you had dust and snow or rain, and still have technologies that would allow to see through all that.
Was radar sort of new as a robot sensor at that point, or?
Not necessarily. I think that it was, no. There were prior projects that would have used radar, and there was research being done both in the US and in Australia around field robotics, using radar for perception. But the challenge was, radar is a very noisy sensor. It has side lobes and a bunch of other characteristics that make the interpretation of radar very difficult to actually create a model, create a scene that actually would be useful for a robot to plan.
Yeah.
So we were marrying the use of evidence grids, which is a probabilistic methodology to actually reconstruct geometry of a scene using noisy sensors, and radar. And I guess that was the key element. Also, we were looking into making radar solid state, so it would be able to scan without any moving parts.
Was that not being done at that? Okay, that's interesting.
That was being done, but for military applications or for very distant, but at the millimeter wave frequencies, so that you can have a more detailed, shorter range modeling. That was not something that was commonly done at the time.
That's really interesting.
Mm-hmm.
So would that have been custom electronics then?
Well,
were you taking...
The interesting thing is there was custom electronics, but also custom radio frequency phenomena, whereby emitting light, we would be able to change the characteristics of a grid, and that grid would be able to transmit more or less intensity of the radio frequency. And by doing that, you would be able to shape a beam into a specific direction. So it was the intersection of robotics, probabilities, and some physical, opto or electromagnetic and physics phenomena to bring this capability together to form a non-scanning, mechanical scanning radar.
That's awesome.
Mm-hmm.
Yeah, I mean, I'm very, very grateful for electronically steered radar, and that's neat to hear that like a lot of the civilian use started at the NREC. And so,
that was fascinating, right?
Yeah. What was your involvement in the project? Like, how did you get in? Like, what sort of things did you do there? What were some of the discoveries?
Right. So the radar had been brought up by some projects with Caterpillar prior to that.
Cool.
Keith Lay is one name that comes to mind, as well as also Sanjeev and others, right? Bringing the radar to be able to scan, but that was mechanical scanned, and try to understand the shape of a pile of dirt, so they can actually plan the excavation of it, the autonomous excavation.
Yeah.
And it became clear that whenever you have moving parts in any mechanism, there's a question of reliability. So the question is, how can we actually get rid of the moving parts, and also what is the mathematics or the methodologies that would enable the integration of all this data so that it would be useful for planning. So Hans Moravec, who was part of my thesis committee, Hans had been using evidence grids to successfully map using sonar. Now, sonar and radar have similar properties in the sense that those are both
the side lobes, for
right?
instance.
Side lobes and waves, and you have also things bouncing off, and then you have repeated echoes coming in. So to be able to make sense of all of that noisy sensing, then is when you would have want to bring some mathematics, and such as Bayesian filtering or occupancy grids and things like that.
Yeah, that's really cool. And for like people listening, like an occupancy grid, if you don't know, it's, I think, and correct me if I'm wrong here, because it's been a while, but I think it's when you've got like a bunch of essentially, like, I guess voxel would be the word.
Yeah,
like,
voxel, yes.
You've got a bunch of like basically blocks existing in space, and based on where you see stuff with your sensors from different perspectives, you mark them as having stuff in them or not, and that's
Right, and the integration, the Bayesian formulas is what you use to integrate data over time, and of course you need to build some sensor models and things like that.
Yeah.
Yeah.
Really cool stuff.
Just a comment about that. Even today, once in a while, so there are some sites that actually would contain a number of papers, academia.org or edu or something like that. So I subscribe to that.
Nice.
And once in a while, there is a notification that says such and such person read your paper, right?
That makes you feel good.
Yeah, exactly. So that's good that some other people in the today are looking into that experience. And of course, in these papers and theses are things that work and some things that don't work. And hopefully that is a foundation for others to get much further.
Yeah. It is awesome kind of seeing some of the new tech coming out in robotics these days. And even when I go to Carnegie Mellon, I think I mentioned when we had dinner, I gave a talk there last night, which was really fun. The new students are getting just, I don't want to say smarter because they've always been smart, but I don't know if the technology is just getting better or the programs are getting more advanced. Like I went to so I did my master's in robotic systems development there, and I went to the MRSD demos like last year, and their stuff was so much more impressive than ours. Like it's just getting better and better. Yeah.
So I think that maybe the fundamental thing that is happening is that, for example, 20 years ago, you didn't have these powerful boards that would be processing optical information real time with FPGAs, and nowadays with dedicated processing
GPUs,
unit, GPUs, or processing units that actually can do the equivalence of execution of neural networks right in parallel and real fast. In the past, we had to build all those things, right? We had to actually create the boards and integrate the components. But now they have become so standardized that then you can use those as reliable components to build more sophisticated systems. And if you take that into software, for example, you may remember that time when you actually needed to pretty much program any function until, for example, let's pick one language, C++, right?
Sure.
Or even C. Then you start seeing the emergence of these libraries that had been tested. They were working,
nice.
For which the interfaces were well defined,
A
right?
big one. Yeah,
yep,
it's a
exactly.
huge one.
Yep. So then what happens now is that instead of having to work on the fundamental algorithm, now you can count on that piece of software being reliable, and you can integrate and you can start working on the next level of sophistication and integration. So I think that is the stuff that comes out of labs today is so impressive because it can count on stuff that we did before. And again, has been tested, has been proven, for which there's documentation, for which there is good interface definition.
Yeah, it's huge. That makes a lot of sense. Okay, so we're standing on the shoulders of giants, and
yep, that's a good way to say it. Yes,
iterates, with every graduating class or group of engineers, or just every year that humans are about making more stuff. So yeah, that makes a lot of sense.
Right. Yes. Of course, you're bringing a number of concepts and ideas, but we're going to see how this conversation goes.
Yeah, absolutely. No, I'm trying to keep it like sort of like advanced, but also like just ground it for people listening that might not know some of this stuff. Mm-hmm. So I kind of go back and forth between like like if someone uses acronyms, I always be like, okay, well that stands for so and so.
Yeah. No, that's very good. Can I jump to the future and then come back?
Yeah, absolutely.
So. Today, at Balanced Engineering, we're really, really focused on robotics and automation and digitalization and helping companies go from more traditional products to highly sophisticated, autonomous or highly automated products. But there's a key piece there that has to do with safety. And safety is really a function of understanding the multiple modes of operation, the interfaces, the reliability, the redundancy, a number of things, right?
Yeah.
My point is that if you need to build a safe system, thinking of all of the components, the subcomponents, is going to be very, very difficult. So now let me go back to where we were talking. The building of components that have been tested that are reliable, that are well known, is a foundation to really understand to what extent a system is going to be safe. Because it's going to be a function of the components, right?
Sure. And considerations too. I mean, of like what happens if you have to lock out the robot, do you just cut power to all the motors? Well, not if it's dynamically balancing.
Right. Or not if it is going 60 miles an hour in a busy highway, right?
100%. Yeah.
Or not if it is for example, a wheel loader backing out at high speed with a bucket with a few tons of dirt. No, really. I mean,
no. I'm laughing because it's true. Yeah.
Yeah, exactly.
It wouldn't go well.
Disconnect the motors, and you're going to put the system in an unstable condition, potentially leading to an accident. So this idea, for example, of the e-stop that actually interrupts power and stop things.
It works in some cases.
Yeah, of course. Yeah. Of course. But nowadays, especially looking for more and more performance, we're getting to systems where the stability is guaranteed mostly because of the software and the controls. And if you disconnect all that, the stability is not guaranteed anymore.
Yep, totally true.
Yep.
What are some other interesting safety cases that you kind of get into where it might not be what you would think it would be just intuitively? So
the aspect of interaction, human-computer interaction, and moreover, human or worker and robot interaction has a fundamental place in trying to understand whether technology is going to be safe. But that it's actually, we can actually take it from humans, right? In how, when we interact, when we work together, you're going to see that very quickly, anyone working in a factory or in a field or a soldier is going to train, is going to have good communication, is going to have an understanding of situations, reactions, etc. But a fundamental element is that you want to know how the other person is going to react or act.
Yeah.
If you have that, then you will trust that person and you're going to be a great team. But if one of the two or the many is not trustable, is not predictable, is kind of erratic, then you get yourself into unsafe situations. So I just take that concept, right? Yeah. Let's take it from something that we all know, and let's bring it to the safety of interacting with highly automated systems or even fully automated autonomous systems. Well, then you want to make sure that the behavior of that system, is intuitive, is expected, is known, and that leads us to there's a number of acronyms and expressions, but there's this idea of automation, state, and intent communication. In other words, how does that machine communicates to the human the state? Am I safe to approach? Am I working? Am I moving? And the intent, I am about to do this. And that is all we want with human interaction. What? Tell me what's your state and tell me what you're going to do. So that is one fundamental, answering your question, element that is not always considered or appreciated enough in what drives safety of automated systems.
That makes a lot of sense. I mean, that's kind of almost a human factors piece.
Yep, absolutely.
Yeah. That's really interesting.
So that is one of them. Of course, there are others, and maybe I don't want to bore you or the audience.
This is interesting to me.
Yeah, to go into a number of others. But of course, when the reliability of the system, meaning how many thousands or millions or billions of hours is a system expected to operate correctly. And if components do not have, such a level of reliability to meet up the system's expectation of reliability, well, then you need to get into things such as redundancy, right?
Sure.
And then you get into, especially if you're into control systems and software, you start to get into the realm of functional safety, right? Which is this very dry, very painful, but very important area that if you're able to show how your system will operate, it has the redundancy and can operate at a certain level of performance, then you can start to, if not guarantee safety, but have an expectation of safety that is, reasonable.
Yeah. So give me an example of like a functionally safe system, or where maybe functional safety would enter into a system.
Yeah, of course.
Or into an engineering project.
Yep. So, for example, I'm going to use a recent project we had.
Sure.
Boats, fast boats, boats that are so the fishermen of bass or other fish, they like to go real fast from one side of the lake to the next, and they cruise at 70 miles an hour on the water.
Seriously?
Yes, seriously.
That is quite fast.
Yeah, exactly. And by the way, I'm just going to show you why this is so critical. If you're in a car going at that speed and you see that there is a problem ahead of you, you have two main functions that allow you or may allow you to avoid an accident: steering and braking. Right?
Yeah.
So you're going to use one or the other, or maybe both. If you're going at 70 miles an hour on a lake, there's steering, and that's it. There's no braking, right? There's no braking, and you can slow down, etc. But if you are in front of let's hope that never happens to anyone, a swimmer that you had not seen, right? Or if you didn't see a rock or whatever, the only thing that you have in front of to avoid the accident is just to steer. So then, because of that, the steering of a boat that has several hundreds of horsepower in the back is really critical. A failure in the steering can actually deviate you from where you are to run aground. And don't go out in YouTube looking for accidents of boats, because they're not pretty. Gotcha. So then the criticality of the steer-by-wire, where you have someone in the front with the steering wheel, but not anymore, in order to get the performance, not anymore the steering is done with cables, like physical wires, cables, or with hydraulic systems. Right now is computers talking to computers.
That's interesting.
Right? So if you have a boat, it's subject to water, and salty water if you're in the ocean, and a lot of rain, all of these connectors may rust. All of these data buses may fail.
Yeah, makes sense.
Right.
Everything wants to rust on the water.
Exactly. So then that is the kind of risks and the considerations that you're going to start taking, so that when you look at the steer-by-wire, you have very high levels of reliability. So, and if you don't have enough, then you're going to have independent buses, redundant buses, data buses, so that you're going to be able to guarantee with a very, very high confidence that system is never going to fail, almost never going to fail.
That's interesting.
Right?
So there will be a failure, but when that fails, it fails over to a different system. Mm-hmm. And you know that you've suffered a failure there, so you can get it serviced.
Right, exactly. Yeah. So then you're going to have someone that is monitoring the consistency of both data buses. You're going to be having a checking for the integrity of the data. You're going to be having oversight on the controllers, so that then it's very, very, very unlikely that anything is going to fail. And if it does, that there's a redundant system that is going to take over.
That's awesome.
Is that a good example? I mean,
that's a great example.
Okay. Yep.
I'm thinking of the voting system that you see in space, where maybe you have like 3 redundant systems, and
right.
Then there's this idea of voting to determine what to do next, and maybe there's even 4, and 1 is disabled and as a backup for the others. So.
Mm-hmm. And I'm going to tell you up front that I don't have enough experience with space to even be able to comment, but I wouldn't be surprised, because the ability to actually fix anything out there is very remote. No pun intended. Or maybe I did.
That's pretty good. And to be honest, I've not done a ton of work directly on space. So I interned at SpaceX, but I was in IT systems, like nothing, that was on the spacecraft. And I worked in a facility that made rocket engine parts. And small factory here in Pittsburgh, but. I've not actually like been responsible for an engineered space system yet, like directly, and so a lot of this I hear from my friends that work on this stuff, and it seems like fun. So
and if you want to talk to people who are really, really into functional safety to a level, you talk to people in space and also people who work in medical systems.
Oh, those are fun too.
Yep. Yes, and of course you don't ever want them to fail.
Yeah, absolutely.
Yeah, every example, pretty much every example of failure in the control systems of medical devices is not pretty.
I mean, the good thing, though, if you do have a surgical robot at least fail to non-functional, is you've got one or two surgeons in the room.
Right, yes.
And so, I mean, I interviewed Ken Urish, who's a physician that qualifies medical robots on this podcast.
Oh,
and
interesting, yeah.
Yeah, he was saying that, like, if and when the surgical robot fails, he knows how to do the surgery. So he's like,
right,
all right,
yes.
get it out of there and we'll finish it manually.
Yep, so. I fully agree with that. And that is from the overall procedure. But at the same time, the way the robot goes in and the way the robot goes out, and making sure that it doesn't go out in any other way.
Oh, sure. I mean, if you're doing a non-invasive surgery and you screw up that support angle and end up making a bigger incision, that's horrible.
Yeah, the example that came to mind that I read as I'm trying to look for example, in other industries is it's an unfortunate integration of certain input components with a machine that was meant to provide radiotherapy.
You're talking about, I just watched this video. What was it called again?
I forgot the specific name, but really it was...
something ACK.
It was the failure.
Right.
So it was the interface and the input system were not prepared to actually deal with something as impactful as, the level of radiation for a radio. So after, quote, roasting or cooking, right, a few people,
like a dozen,
then it became clear that there was a problem, etc. So this whole field of product safety, and moreover, when we talk about controls and software, and much more now with components that relate to artificial intelligence, then what's the work that you do ahead of time so that you can prove a safety case before you deploy the system in any of its intended use or foreseeable misuse, or even when it fails, that in all of those cases you have done your analysis of the system and you have put the requirements so the system will behave and degrade in a safe way.
Awesome. Yeah, it seems like that's a big thing in aerospace too, like just general aviation.
Yes.
Because you don't have a huge factor of safety on like a jet airplane, for instance. But they very rarely crash. And
so I'm a private pilot, and awesome. I love flying, right? And this weekend, actually, I'm very excited because I belong to a flying club, and one of our planes had to have a very thorough inspection of key safety critical parts. But now that it's done, we need to put it together, right? So
nice.
We're going to go, and some of us help, and of course, the certified mechanic, right? To start putting it all together. And I'm sure that I'm going to learn a ton. And
awesome.
It goes beyond just flying the airplane, but understanding how things come together.
That sounds like so much fun. I briefly considered getting a pilot's license, and I still haven't done it yet. I feel like I should. What are some of the things you, I guess, how do you get into that? And like, what are some of the things you have to know about and be mindful of, like when you're flying a plane?
Easy. You come with me on Saturday, because in the afternoon I'm going to go fly.
Yeah?
Yep. No,
right.
For real.
Yeah, let me check my schedule, but I'm very much in favor of that.
3 days later.
But in any case, it's you had asked a few things. Of course, there's a little bit of money, but not so much. And also there is the commitment to actually learning, understanding, and practicing a number of regulations and agreements. It's a system. It's an activity. It's an activity that where you are always trying to think 2 or 3 steps ahead. So, for example, there are some guidelines into that you're not going to fly more than X without leaving 30 minutes of reserve of fuel, so you have a way out if there's a problem. And if you're flying under, instrument conditions, which is when you're flying without always visibility, then you need to leave more, and you need to have thought about an alternate airport, right? And if your radio fails, then there is a procedure what to do with a failed radio. So it's a lot of what if, but that's the way that industry, even though we're talking about being up in the air with an airplane with just one engine, right, that has a large number of parts that could fail, has the level of safety, a great level of safety that it shows.
That's incredible. Mm-hmm. And I mean, no miracle. It sounds like a lot of human thought and consideration goes into keeping that the case.
Yep, and always continuous improvement. That is, whenever something happens, you go in, you investigate, you get to the root cause, that root cause analysis, and once you have that, you go back to the manufacturer, the pilot, whoever is where you can continue to improve the overall system, which is really nothing more than what we all try to practice when we do engineering as well, right? So
absolutely.
I guess there is some affinity between if you have some engineering mind and flying airplanes, but that is really there's no exclusiveness. There's a bunch of physicians and lawyers and all kinds of people fly airplanes, right?
That's awesome. Yeah, I mean, I feel like, as engineers, I mean, we weren't born engineers. I mean, we decide, like, we could have been physicians or lawyers if we wanted to, but we chose to become engineers, and so.
Yep. I when I talked to so I told you that my daughter is going to start geology. Sometimes I feel that is what I should have studied, but then I talked to a physician, right? And it's like, oh my goodness, that is so interesting as well, right?
That's how I feel when I talk to somebody that works on space robots. I'm like, that looks like fun. I want to do that.
Yeah. So. Hey, it's interesting because I'm going to go back to Red Whitaker.
Sure. Guy works on space robots.
Yes, but not because of that.
Yeah.
He has a saying, and I'm sure that he said this to many, if not all, of his grad students, and that is, you can do anything. Truly, you have the skills, the brain, the motivation to do anything, but you can't do everything. So it's all about choices.
Oh, that's interesting.
Right. So, and that has stuck with me, because if you don't practice that in real life, of course, especially for someone who is interested in many things, you can do many things, but you're going to do all of them half-assed, in a mediocre way.
Yeah.
So it's by keeping the focus and just getting at it and learning and improving.
You can then use your whole ass.
Right. Yes.
Yeah. No, that's the thing of beauty. I actually really do like that phrase. I might steal that. You can do anything, but you can't do everything.
Quote Red.
Yeah. So saith Red Whitaker. Yeah.
Yep.
But no, that's the truth. When I was growing up, I read this book called Surely You're Joking, Mr. Feynman.
Yes.
Great book.
Yeah.
And that's one of the things he talks about is, like, I'm a physicist because I spent time learning about physics and, doing all the stuff. And, I mean, anyone could do this if they spent enough time doing it, which, probably not the case.
Yeah, exactly.
Richard Feynman's level, but still.
He was a bit more than a bit humble, but nevertheless. Well, what you have there is really the ability to think long enough so the abstractions that you're building in your head start to make sense and connect to each other. So the concepts, the equations, they start to make sense, right?
Yeah.
And the challenge is that is all abstract. So here we have a cup of water, right? And we can touch it. And the key thing is that it's one thing to imagine a glass of water, you can touch it. Another thing is to build future concepts by the integration of concepts that you cannot touch, that are beyond your senses. And that requires a discipline of thought.
To actually get it right, too, requires
Exactly.
incredible.
Exactly.
Yeah.
because we are programmed. We were talking about genetics earlier, right? But effectively, we are really, really good because those of us here exist because of the genetic pool was able to actually make us effective in dealing with the world, right? Dealing with
over
threats.
Millions of years of dying off if you didn't do that stuff.
Yeah, exactly. So all of our, parents and grandparents, they all could eat. They all could find food. They all could manipulate things. They could take care of themselves and so forth, right? Well, we have a brain that is really well trained to do that with things that we are closely related to our senses. So this idea that we can actually do the same and imagine and plan and build concepts based on abstractions that are outside of what we can sense, I find it fascinating.
Well, to me, what's incredible is like when you learn about computer science, like from a historical perspective, and you find out that like a lot of the algorithms that we're putting to work now, like were conceptualized decades before they were feasible to implement, and somebody figured that out.
Yeah.
It was like, that's what you could trust me on this. It'll work.
Exactly. It was like decades later that actually that was able to be put into practice.
Yeah. But I wonder though, like for all the ones that worked, like how many crackpot ideas there were that like someone was like, trust me on this, and it's just total horseshit, like.
Oh yeah, exactly. and of course there was the bias, right, in the sense that many a times we do remember
the stuff that worked.
Exactly. Yeah. And well, in a way, you need if you didn't do that, if you remembered everything, even the stuff that failed, and you did the statistics of success versus failure, I'm wondering if you would even try, right?
Oh, interesting. Like if you just remembered as vividly all the failures. Some failures I feel like are vivid in my memory. Like I will never forget the time I had to. I never forget the time I had to. I was thinking of like Tom Lehro's Lobachevsky bit, but I'll never forget the time I had to run a BattleBot out of a competition that was on fire because a lithium polymer battery caught fire while we were charging it because the cells were unbalanced, and we had to throw it into a thing of cat litter or sand. It was one of the two. And sprint to the door and get it outside, and then you could just wait. That's all you could really do at that point. But, I'll never forget that. I'll never forget the time a wiring harness caught fire in a robot I built in school because one of the power contacts, the negative one to be specific, shook loose, and the 160 amps that was going through the power electronics looked for a return path in the signal electronics and burned up the wiring. I'll never forget the time I had to chase a robot, the same robot actually, across a street because I didn't put an emergency stop in it because I was stupid and they didn't teach me that in school. And I didn't think, why do you want an emergency? That's ugly. A big yellow and red button, screw that. And so, I chased this thing across 2 lanes of traffic and jumped on it. And luckily it didn't break my arm. It weighed about 80 kilograms. And I was able to pull the master disconnect, from reaching inside the electronics bay and not getting mangled in the process.
Well,
stuff sticks with you.
It seems to me that you did not do a thorough risk assessment.
No, of course I didn't.
Hey, but by the way, I just wanted to take advantage that you said that. When after we haven't even talked about John Deere, but when we talk about John Deere, there was an end to John Deere, and John Deere is a fantastic company.
Awesome.
And I'm just there's one word that describes how I feel with that company, and that is gratitude. Of course, gratitude for the financial progression, for the fact that I was able to live in different countries, that my kids grew up, very internationally, etc. But also because of how professional they are as a company, and all of the opportunities to get to know a business from so many perspectives. But I wanted to fast forward. Why am I in Pittsburgh, right? And one is friends, great friends. Second, I had just a great time here that I thought it was great to come back. But also, if I thought, where could I make a contribution to the robotics industry? I don't think that at this point I could actually develop the technology. There are people with much better tools, systems, connections, even money to develop great technology. But working in a company like Deere, understanding that it's not just the technology, but all of the other elements that make a technology a product, and eventually that product is sustainable business. That is something that we have gone, not just myself, but also everyone in my company, in the team. We have decades and decades of experience of taking technology to the market and making that a business. So that's something that I feel that could be used here. And I'm not being arrogant, because there are many other people who are really good at it, a lot of success, etc. But when I think of that, why did I fail when I failed in bringing robotics to the market? Generally, it was because of the lack of attention to safety.
Oh, that's interesting.
Yep, and you would have the best autonomous tractor or mower or stadium mower, and you would have shown that customers loved it. Everyone loved it, and you get to the safety people, and they would say, well, safety engineers, and the liability lawyers, who are the ones defending a company in front of accusations.
Yeah.
And when they start to look into the potential risks and the potential accidents, they would say, there's no way that this can go to market. And that happened to me. And you were talking about, what you learn and the failures and the pain. And pain is a great professor.
Amen.
Amen. Yes. Then is when you think, well, we need to continue working hard. And for 100 people who are working really hard to make robotics to do what they're supposed to do, the functionality, there are not enough people who are at the same time working really hard to make sure that product is going to be safe. So it's like we went through the pain. Actually, that brings me to another saying. Do you know where good judgment comes from, or what is necessary for good judgment?
Having had bad judgment in the past?
Yeah, yes. It's kind of indirectly, right? Good judgment is based on experience, and experience is based on bad judgment, right? Yeah. I have a lot of experience.
Well, it's funny you say that, because I feel like anytime I've ever been in a machine shop and gone through a training and somebody is like, hey, lubricate your drill bit, or, don't use the machine tool sleep deprived, or make sure your jaws are closed all the way, or, one of these things they say that might seem draconian to a young student that's never worked in a machine shop before. The reason they say those things usually is because they've seen it go horribly wrong. Yeah. Or someone else has seen it go horribly wrong, or, like best case, they watched a YouTube video of somebody else getting hurt because they knew it the right way. I mean, worst case, they themselves, made that mistake, and they're telling you because they've seen what happens when you don't do that thing, and they're trying to cover your rear. So.
Right, and also I'm going to make a connection with what you just said to a business. Remember, I didn't just say technology to a product and product to business. I say product to a sustainable business. And that word sustainable is not by chance. It's key, because you can have a great product that sells a little bit and then causes some accidents, and you're going to get a lawsuit and you're done, right? So that sustainable business is based on being able to continue to supply whatever it is that you're building to your customers over and over and over. And you're able to teach your customers how to use the product over and over and over. And you are continuously to improve the quality and and the serviceability, and you have the spare parts, and you have all of these things that are really, really boring to someone who is trying to build a cool robot. But again, a cool robot is not by itself a product, let alone a sustainable business.
I don't know if it's that boring, though. I mean, the more I learn about, quality, or like design for assembly, design for maintenance, I mean, that stuff's it just stems from experience, like you said. I mean, it's, how would I interact with this if I wanted to change out a component that had failed? How would I put this together if I were an assembly technician that had to build this thing, with my own two hands,
Or I'm going to put it more real, right? And being a rancher, I know that, and also having worked in customer support in Deere, I know that too well. You have a crop that is ready to be harvested, and rain or snow is coming in, and you have enough harvesters to actually be able to cover all your acreage on time before that weather pattern comes. And what if your machines fail? And then the technician comes and is trying to fix. But in order to replace a component, you will have to open half of the machine, and that is going to be 3 days of work. As opposed to placing the likely to fail components in a place where they're easy to access, and that can be done in half an hour. Which machine would you prefer? If this is the first time that you buy a machine, you wouldn't even think about it.
Yeah.
When you lost your crop and you lost money, then you're going to think about
3 days of downtime, plus you had to pay a technician for that.
Exactly. So I guess that the uptime, whether it's mechanical or operational, continues to trump over a number of other factors. And sometimes we engineers are trying to, for example, work on becoming 3% more fuel efficient.
Yeah.
And we spend all of this money in, all kinds of things. But when you look at the total operation of your customer, maybe if you were more careful about how much product, like a fertilizer or a chemical, a weed killer or something like that, if you just were able to reduce that, that would mean significantly more money than the 3% fuel efficiency that you're. So that's why it's so important. And you and I were talking about systems engineering earlier, and the system is not just the equipment. Sometimes we need to be thinking, what is the production system? If it is a construction company, what else is at play? It's not just the loader, not just the backhoe, not just an excavator. If you are a farmer, it's not just the tractor, it's all of the other pieces that are trying to make money for that company. And I think that we need to be thinking of this broader scope.
Yeah.
To really justify, are we fixing the most important or most critical to profitability parameter?
Yeah, makes sense to me. Context.
Yep.
Like actually knowing why.
Exactly.
Yeah. No, I've definitely made that mistake of getting hyper fixated on something and optimizing the wrong variable as an engineer. I mean, it's interesting because I feel like, anyone that knows how to do systems engineering, I think, and maybe this is, hopefully this doesn't rub anyone the wrong way, but, I'm of the belief that, the best systems engineers are people that have done lower level engineering disciplines before that. And, maybe you've written software or designed mechanical components or serviced a machine or, built electrical harnesses or performed electrical engineering, schematic capture, all the above, and all that informs, your position as a systems engineer, I think. And
that is because you can make it real, right, as opposed to some abstract, detached from reality thing. And by the way, this in no means criticism to the abstraction that we were talking about physicists, right? But
even that has to be sort of attached to reality in some way. Like it's got to be grounded. If the assumption, if you base your model off a false assumption, then your model doesn't work anymore. Like at a certain point. So,
correct. Yes. So. Right. At least you need to have an understanding, of how complex it's going to be to write code and how risky it's going to be if you don't pay attention, and or
how a mill works or your manufacturing processes. That goes down a level from systems engineering, but we've all seen the example of the machinist that hates the junior mechanical engineer that will design overhangs into a milled part so it can't physically be milled. I mean,
Yep.
yeah, like that's
because it looks good. But
but
actually,
it doesn't make sense from
Right.
a manufacturing perspective.
actually, I'm going to go one step further from your example. You should be really, really, really thinking about the guy who is so enamored into design that he will want to create a new part as opposed to reusing the part that exists.
Oh, that's interesting.
Yeah, and the reason I say that is the following. So let's say that you're building the next generation piece of equipment, whatever that is. And you have a choice. You can actually use the old part, and that exists, or you can say, hey, I can do this better. All right, so you may improve the quality, you may improve the looks of it, you may improve the cost a little bit, and those are all good things. The question is, in your assessment as to whether you need to design a new part versus using the old one, did you consider the cost of inventory of keeping that part in all of the parts distribution centers for your company globally, plus having those parts in each one of the inventories of the hundreds and hundreds of dealers around the world? Because when you look at the cost of a new part in all of this support system that is going to have the spare parts, in depots and then in the dealers, and the number of parts and the possibility that you're going to put the wrong part because they kind of looks the same but it's different, right? So you're creating unimaginable cost and risk in the system, in the support system. And of course, you're going to have maybe the award of the best new whatever, right?
Yeah.
Because it was so coolly, designed so greatly. No, you may get a design award. But as a business, it's a disaster.
Yeah.
Because you have populated all of these stocks with more parts, more cost, and the technicians, if they're not well trained, may confuse one part number with the other, and now you have a real problem. Snow comes in, you didn't harvest the corn, and the farmer lost money, and he's so pissed off that takes the combine back to the dealer and says, I don't want this, I'm going to go to the competition and get theirs. See how the story comes together?
That is beautiful. All right, so devil's advocate, right? What if you made a better designed part that's cheaper, slightly more efficient and prettier, but had the same interface as the old part, so they're interchangeable?
Well, that's great.
Okay.
Modern and mature companies have the parts management systems that will enable to populate all of the communication and the training to all of the dealers that this new part supersedes the old part and whatever, right? So that is.
But the old part will work in a pinch. Like you can still.
Yes. Well, all I'm saying is that if you have such an improvement in quality because maybe the other part failed, or you have a reduction of cost so you can improve the margin, right? Or you have cost quality, or maybe something that relates to the performance, right?
Yeah.
So of course, but again, that has to be weighted.
Yeah, well, the tooling cost is non-negligible. Like you said,
Yeah.
the inventory and production cost is non-negligible.
Do you know why my company is called Balanced Engineering? Exactly because of that. It's because engineering is nothing more than a very large number of trade-offs.
Yeah.
And at the end, you win when you have a balanced design between performance, cost, quality, serviceability, safety. Well, safety is not even has to be safe, period, right? Yeah. And so forth, right? So I think that defines what is important in engineering, which is to strike this balance.
I completely agree. Another interesting one that I similar, not to belabor the point, but I feel like I learned about late in my career is just uniform fasteners on something, like using the same bolt, even if like maybe you can save a little bit of weight by like using a bunch of smaller bolts and then bigger bolts here. It's that's a big one. Or if you have like bolts that are the same diameter but varying lengths, like that is a nightmare for a technician, because like to know what to use where is you're never going to grab the right one when you're trying to put that thing back together.
If it is too long, you may break something, tighten it or Yeah.
Yeah, and if it's too short, you might not have enough threads of engagement, and it might pop out in operation.
Mm-hmm. Well, and going back to, it almost sounds that I wanted to just criticize that engineer that was so excited about
That
creating.
hypothetical engineer
Yep.
that
But
probably exists only from an example of an experience you had at some point in your career.
No, but I guess that my point is that I'm convinced that we all are trying to do the right thing. Truly so, right? Truly so.
Sure.
But the question is, do you have the complete context? Do you have all of the parameters that you need to weigh to make a decision, right? And that is part of the more large companies grow, they become so specialized, and not just themselves, but each department. The mechanical engineering department will become, a large number of people, and they have their own processes and their own things, and then the electrical guys, and then the software guys, and then the service guys, and then of course the accounting guys, and all of these functional areas in an organization.
You're talking about siloing.
Yes, I'm talking about siloing, and of course that specialization is what enables this great economy of scale that makes these companies just incredible money-making machines. But at the same time, at some point, people stop talking to each other. And now being able to further optimize becomes really, really, really difficult because it gets to the point that people are not talking the same language as each other, right? Anyway, so I'm just thought about that, is that, of course, what is in the recipe for success becomes a problem, and then because of all of the rigidity of the processes and the organization, then innovating is not as easy anymore.
Yeah, that makes a lot of sense.
Yep.
Yeah, it's an interesting thing because I've worked at large companies, but not for extended periods of time. I spent a short amount of time at Joy Global after I finished my master's degree. I don't even know if SpaceX counts as a large company. There were 3,500 people when I was there.
Yeah.
It's medium-sized.
Yeah.
I don't know. I've worked for larger companies in the context of clients that we've had at SKA, but for the most part, it's kind of like from the outside looking in. I most of my time's been spent at the small engineering company, and then a little bit of time at when I was at Deep Local, I think it was 25 people. Now it's just over 100, 150. There's other places I worked where it was pretty small. So I don't think I ever saw that level of formalization and siloing. So to me, it's really interesting to hear kind of about that trade-off, because I don't think you can be at the scale of a Deere or a Caterpillar or a Joy Global or whatever, Parker Hannifin, Johnson & Johnson, take your pick, without kind of compromising a little bit on creativity in order to establish systems that are able to get that large. And
right, you're absolutely right. And because there will be a lot of variability in who you hire, you need to reduce that variability through processes. And then you provide recipes and clear steps in how you do A, B, C, D. But then the processes become so strict and over prescriptive that then there's no much opportunity for change, right? And in a way it makes sense, right? Because once you created the first generation of a car or a excavator or whatever, you'll get to the next and you're going to get all of that experience and you're going to put that in the process, and the next one you're going to get better and better, right? And after 10 generations of products, even the product development becomes highly standardized. No, really.
Yeah, I'll buy that, but that's interesting to hear about.
Yeah, because normally what you want is that the manufacturing becomes highly standardized, right? Yeah. But then even the engineering process becomes highly standardized, right? So then every time that you actually design the new generation, you're going to make a ton of assumptions in terms of the architecture. What's the value assumption? What's the market likely volumes, etc. So then it's going to be another thing of more or less the same.
And all your decisions are probably data driven at that point because you have enough data from
Yep.
the previous generation of the product and generations in this case to be
Bingo.
able to do that.
Right. These are, other business elements
Yeah.
that need to be considered to be successful with the product and making a business. So you can sell enough that you can pay the NRE, the non-recurring engineering, etc. So what I'm trying to say is that it is not just difficult for a company to innovate from a technology point of view, but even to market the technology, you need to articulate new value drivers and be able to communicate those. So when you innovate in technology, you're challenging many of the other areas. Even the finance guy is going to come and say, okay, very good. So in your estimate, you're going to sell this many next year. What's your precedent? Well, we have none. This is the first time that someone sells this, right? Or only the competition sold this many. Well, how do you know that you're going to sell this many? Well, we don't know. That is our best guess. And in a company that makes decisions based on data, as you all said, that doesn't fly.
That's interesting.
Yeah, so that's how projects get shut down, is because the financial director is going to say, I can't trust those numbers to be able to support the project forward.
It's like analysis paralysis, where like you just stop because you can't crunch or make sense of it.
Mm-hmm. It's really moving away from a company that has done things the same way every time.
Well, we talked about Apple. I thought that was an interesting example for a company that seems to continue to innovate.
Yeah.
In spite of the fact that they're huge. So.
But actually, let's talk about it a little bit. So,
Yeah.
To what extent would you consider that the iPhones continue to be highly innovative?
Oh, not at all. But like, I mean, it's,
Okay.
I mean, it was to begin with. But I mean, like the iPhone 14, I still have an iPhone 12. It's pretty much the same as, like, I don't, I if I'd have known I could have gotten the 11 for half the price I bought my 12 at, I would have bought that. I mean, I think you have diminishing returns as it goes on. But I mean, at the same time, I mean, the iPhone was really innovative when it came out. The Apple Watch is really innovative when it came out. I mean, I think when Apple kind of pops a new product, I don't think it's afraid to, well, maybe some people are afraid to do that, but, I mean, historically over the years, at least, maybe this is more when Jobs was around. I feel like Apple still took chances and released interesting and different things that sort of maybe either flopped, like the Newton that we talked about, or did well, like the iPhone that changed the paradigm for all cell phones ever in the world.
Yep.
And so I don't know. I mean, I guess all the companies that have become conservative are based off of previous innovations and advances, and the conservatism works. I mean, I run an iPhone, like it's great. And when it breaks, I'm going to buy the latest iPhone to replace it. I'll keep, because it's a solid piece of engineering.
Right, and you can count on it, right? It's not anymore a group of people who are willing to try a new technology. These are tools that you wanted them to work over and over. Right?
Yeah, but I mean, I don't know, maybe it's a bad example, but like, I was going to say, like, when the DVD player first came out in like the mid 90s or whatever, like, I mean, you nerds bought them, like it's Silicon Valley people, like maybe doctors with a lot of money, like it's the early adopters.
Remember the large video laser disc?
I do remember that.
That had a really short life. Then it was just replaced by the smaller one, or something happened. I don't remember, but they existed for a little bit.
I mean, history is littered with stuff. I mean, like the compact fluorescent light bulb, right, only existed for like a few years, and you can, anywhere you see one of those, you can be like, that was the early 2000s for like this quick period.
I don't know what you're talking about.
Like those light bulbs that like it screws into a socket like an incandescent
that have
bulb
like
used to. Exactly.
Yep.
What, you saw those for like 3 years, and then they got supplanted by LEDs.
Yes.
Yeah.
You just reminded me something. So Kim quit John Deere, fantastic company, thought about coming to Pittsburgh, and I had a chance to work with Sanjeev, Marcel, and others in Near Earth. And that for me, so very thankful. It was really a reset, in the sense that coming from a very large company with processes and a cost structure and a way to do things, etc., and then you are in the context of a smaller company that has to be very careful with any expense or cash, and where the creation of technology becomes the differentiating things. It's like technology as a capability. So I am really, really happy and extremely grateful to them, because it was an opportunity to actually land, or just
Pun intended.
No, it was not intended, but it's a good one too. No. It was more like a reset to actually understand how business is done in a smaller company. That I feel that it was fundamental, to just leave behind a number of, I'm going to say even approaches, in how you do business that are in the context of a larger company, right? So that was a really, really challenging, interesting time working with them. I loved it.
That's cool.
I loved it. And of course, I am here crossing my fingers so that, they had a round of investment, and
nice.
Those autonomous logistic helicopters become a reality through them.
That's awesome. I haven't been following those guys lately. What are they up to these days?
A couple things. They have an area that relates to inspection, and the use of drones to do inspection of aircraft, or inspection of infrastructure, or inspection of tunnels. Anything that is really, really costly to build or to maintain will benefit from technology that can do that faster and with less hassle. So, for example, if you have a tunnel and you're building it, and you have your crews go in and out, if you had a drone that could go in and out as opposed to a inspection crew, then you don't need to stop the machines doing the tunnel, and you gain productivity. That could be a lot of economic value created there. But that is one side of the business. The other has to do with their just autonomy for flying machines, all the way from the first autonomous helicopter that they demonstrated to the partnership with Cayman, looking to integrate autonomy into autonomous logistic helicopters.
Very cool.
And many other things, right? You should invite Sanjeev. If you haven't, right? He will tell.
I don't know him personally. If you're willing to make the intro,
I will do that. No, Sanjeev is in addition to being
I probably shook his hand once or twice. And,
yep. Not only he is a great human being, so is Marcel, and the rest, right? But also very savvy, and also a really good storyteller.
Oh, that's awesome. Yeah, it sounds like fun. I mean, if you.
Yep. I'll do that.
Yeah, I'd be happy to have him on. Yeah, and I've heard good things about both of them, and I've met Marcel a couple of times. I know that. Just Sanjeev, I've probably talked to him. It's just it's a blur, and we haven't gotten a chance to work together yet. So
highly recommend it.
Absolutely. Yeah. Now, there's a few people. Chuck, I tried to get on last night. I was like, "Hey, when you're ready," and he's like, "You know where to find me." I'm like, "Yeah, I'm asking you now." Like, I'll come in your office and ask you again, but it's like, you'll kick the can down the road, and we'll never do it. But
Well, maybe that actually brings another dimension of the conversation that has to do with talent and leadership, and people who are coming out of Carnegie Mellon, out of the Robotics Institute, and not only fantastic people, but actually that even years later continue to push the boundaries of technology, and more, and this is the exciting thing, the boundaries of the business of technology. Things such as what Aurora is doing with Chris, right? Or we talk about Demi and some of the things that he's doing, and many others. Actually, great. I don't even want to go and start talking because I'm going to be very unfair to many, right? So Ari Square, with Sarkos, and
I had Jürgen on.
Okay. Yep.
Great dude.
Yes.
One of my favorite people in the world. when I first started talking to people from RE Squared years ago, and everybody was talking about Jurgen, I'm not ashamed to say, I thought, what a cult-like environment. Nobody can be that great, like nobody's that magnanimous. And then I met him and I got to know him. Like, oh, he's actually a really, really good dude. Like, I really like this guy a lot.
Yep.
Yeah.
So maybe after the show, you and I are going to go through a roster and see if who else you have not interviewed yet, right?
I'll definitely take you up on that.
Yep, absolutely. Yeah. So in any case, this is what is really exciting, is that we are in a city with and by the way, I'm thinking of another element is that all of these talent fragmented out without visibility doesn't really have a lot of potential, but when they're working together and they have the visibility, and I'm going to give kudos to the Pittsburgh Robotics Network.
Oh, they've been great.
Yeah, Joel Reed and
Joel Reed's been amazing. Jennifer Foessel has taken the reins really nicely. She's a badass.
Yep.
She's done the podcast too.
Yep.
As has Joel Reed.
Okay, very good. So here's something that I would like to see in the future. I'm just going to put this as a not challenge for everyone, but actually an self challenge, right? So we are fantastic in a number of dimensions. But if you go to Iowa, or if you go to California, some places, or if you go to Brazil, or if you go to Europe, Pittsburgh, we are just not known for being a center of excellence of robotics in agriculture. We have companies here. We have had companies here. Case New Holland was here briefly. Deere has been investing at the NREC for many, many years. I don't think that we have seen ACO or some of the other ones. But I guess that my point is that Pittsburgh doesn't have the visibility of having a concentration of technology in the ag area. There's Bloomfield Robotics.
Sure.
Doing great things.
For growers.
There
was fifth season before they had their unfortunate demise.
But if you go, for example, if you go to Brazil, where I have some investments in startups, and where I go often because I believe that is one of the areas of most potential for food production, you ask around and we don't have a brand. So I'm wondering whether in a few years, if this gets more attention, whoever is organizing another group of people from executives of the largest farms in Brazil, or coming to the U.S., that they would say, we're going to stop by in Pittsburgh. There's so much happening that you need to visit that place.
Yeah, you would hope so. It used to be that when I traveled, I would tell people I was from New York or Canada. Certain parts of the world, I thought I had to say Canada, and then I realized nobody hates Americans as much as I thought they did. I mean, some people maybe, but like for the most part, like I had these misconceptions. You kind of just assume people will be mad at you for being from the States, and it's not really true. And then you think like Pittsburgh's kind of podunk in the eyes of the world, and I'm gonna say I'm from New York in order to name a city people have heard of.
Yeah.
And I don't know. I feel like you kind of hit the nail on the head with Joel Reed just doing a great job spreading the message that Pittsburgh is the robotics capital of the world.
Yeah.
And I mean, Jen's been doing that as well, I think, in a really good way. And she's been doing a really good job. I think where she is kind of been, just excelling and taking it to the next level is her willingness and ability to travel to like Odense and like, Boston and the Bay Area and represent Pittsburgh and kind of jump into other areas and set up and show people kind of like.
Yep. The first thing to be recognized, you need to show up.
Yeah.
Right. Show up.
That's right.
Number one.
Yeah. Yeah, and Jen is excellent at that. No, she has been killing it lately, and it's been really, really great. She put out a LinkedIn post with a bunch of people from Denmark, and I remember posting on it and saying, "Oh, I'd love to know the next time you guys do this. And the next day, I received an email invitation to like a event at like, I think it was like the Danish embassy in New York. Like the next day after commenting on that LinkedIn post. So I couldn't make it, but like I was grateful for the invitation.
So recently I've been talking to a robotics ag company in Denmark, and one of the fascinating things is how seriously they have taken, and of course this is very close to home, right? How seriously they have taken into building a full stack of robotic components for ag, while at the same time making sure that they're compliant with the standards of safety as it relates to ag machines. And I'm like, my hat is off to you, because very seldom either you can do one thing or the other, but it's very seldom that a startup or small company is doing both. So I'm going to go visit them later in November.
That's awesome.
We're going to meet in Agritechnica and a very large fair of ag in Hanover in Germany, the largest one in the world, actually. We're going to be presenting a paper about, integration of safety and automation and AI for ag.
It always makes me smile. Oh, sorry, I didn't mean to cut you off.
Yep. But go ahead.
I was going to say it always makes me smile when I see a company doing things the right way.
Yeah. Yes. So no, there's something about the Danish that is, but not the only ones, right? There are some others. It's just that's the company that I was talking to last week, and I was like, my goodness, you guys are really putting the effort, the time, and the discipline to do this right.
Yeah.
And there are many others here in Pittsburgh who are doing the same thing. I'm not at liberty of saying who they are.
Yeah.
But
I mean, I would put RE Squared or like Sarcos now amongst those. I mean, they're. Yes. I mean, it's no secret that SKA does work with Sarcos and
with I did not know.
It's on our website. I mean, it's all been approved. It's above board. But I mean, those guys do things the right way. They're methodical. They're intelligent. They're calculated, measured, and they take the time to go about the engineering process in a calculated, methodical, and correct, but not overly drawn out way. And I'm a big fan of them for that.
I don't know them very close now, so maybe I will go and check it out.
Sure.
Yeah.
Yeah. No, big fan of those guys.
So yes, I was more thinking of companies that are working in automation for off-road. There are a few others in the robotic row, right?
Yep.
And I'm not talking of anyone in automotive, but nevertheless, others are really doing the right thing. Just thinking how the components that they're building can be integrated. And remember that you and I were just talking earlier about OEMs and tier 1s and tier 2s and the importance of remain competitive as a supplier by making sure that your components had the right level of quality, cost, whatever, but also compliance with regulations and standards in different countries.
Yeah.
So I'm delighted to hear the interest that is happening in town by companies who are saying, okay, we really would like to invest and make sure that we can actually say on our website that our gizmo, our component, is certified to this standards, because that's the way they remain or become competitive.
Yeah. No, for sure. It's an interesting thing to me, right? Because, and I sort of brought this up the other day in a event I was at, but what keeps companies complying to standards? Is it, like you said, is it just the ability to say you're doing so in order to mitigate risk and uncertainty? Is it because you trust the standards board to have set a bunch of regulations that if you follow them, you'll end up with a safer, higher quality product? Or is it because you have to in some cases? I'm just kind of curious in your experience.
I'm going to give you a lawyer's answer. It depends.
Okay.
No. No. There are two reasons. Actually,
Sure.
There are three reasons, right? The first one has to do with a standard is nothing more. Let me take the mystery out of it. It's nothing more than really experienced engineers or professionals from a number of companies getting together and asking themselves, what are the best practices that, and as an industry, we know today that are reasonable to apply to product development. That's the fundamental understanding of a standard.
Yep.
And that takes a lot of time and a lot of dedication. And like politics, a lot of argumentation also, because, what are the best practices? My best practices may differ from yours, right? Or if I apply or we express my best practice, it may actually exclude your design. So it is really a very professional conversation that drives to a document that has the best practices in a given field. So if you follow the standard, you're going to be benefiting from the industry best practices in your product development. So the likelihood that you're going to do the right thing are very, very high. So effectively, you're using a standard and complying to it because you're going to get a better product, a safer product, whatever.
Yeah.
Right? That's the reason number one.
It's because really smart people have spent a lot of time thinking about it.
Yep.
Yeah.
And standards, because they're slow to develop, sometimes they become obsolete, and you can criticize them for doing so. Yes, but nevertheless, they get revised. And for example, my business partner Rick, he participates in a few standards, and they're trying to integrate a number of things so that the path to sell robotic ag products becomes clearly described by the standards. So they're talking about product safety and the safety of the intended function and a few other things. There's a second reason, is that if you're ever in court because there was a problem, it is much more defensible to be able to show that you complied with the standard that, as we said, is the collection of the best practices. So you are in a much better place than if you said, no, I decided to do my own thing, and then proving that that thing is better than the industry best practices in the standard becomes a really difficult position to sustain. You can, but it becomes a much more elaborate, complex story. Expensive story than to say, hey, here's the standard approved by the industry, and here's the documentation that shows that I designed to the standard and I tested to the standard, and here's the documentation.
Makes sense.
So that is reason number two. It puts you in a more defensible position. And reason number three that you also mentioned, that if you want to sell in Europe, then you're under what it's called the machine directive. This is a regulation that will require you, among other things, to sign a certificate of conformity. And in a very explicit way, that certificate says that you are affirming that your product was developed under the applicable industry standards for that product.
It seems vague.
No, it's very clear.
Okay.
It's very clear. You're saying, if I am bringing an ag product to the market, then I am complying with the applicable industry standards that apply to that.
But who's to say what's applicable to your product?
Oh, well, if it is an ag product in functional safety, there's no other norm that ISO 25119.
Okay, I see.
Yeah. So
fair enough.
Yep. Yeah. Yep. Or and if it is a component, you could say that, it's ISO 26262, that is more automotive, but the standard accepts that other standard, and there's ways to demonstrate that you're still doing the right thing.
That makes a lot of sense.
Yeah. So there's integration. So 3 reasons: making a product safe for real, not just to check a box, but for real.
Yeah.
Best practices in the industry. Second, you have a more defensible position if you're ever having to explain why an accident happened. And third, if you're in Europe, you have to comply.
Yeah. And there's clearly defined, best practices for which industries and applicable.
For the most part.
Yeah.
But so there's some, but yes, for the most part, that is the case.
Yeah. That makes a lot of sense. I appreciate you taking the time to dumb it down for me.
Yes. No, and that's why I find that, again, sometimes if you are developing a new system and you look at that and all of the requirements, you may say, my goodness, this is going to be so expensive. Or, I don't think that this is the right way to design a product. I know better, right? Etc., etc. But again, what is your objective? Is to create cool technology? In that case, I would say don't even pay attention to the standards, right? Is to create a successful product? You really should be paying attention to the standards, right? But if you are in business, if you exist, if your company exists to create a sustainable business, my friend, you need to look into all of these documents and have a strategy in how you're going to comply. And maybe you do it at the beginning with just some pieces, but at least you will be able to show and you will you'll have the confidence that if you're picking a few pieces, the important ones, and then let's say that the next round of funding comes in, if you're a startup, then you can pick a few more. But the important thing is that at the end of this journey, you're going to be able to look back in the eyes of your investor and say, yes, our product will become a sustainable business because we have the best industry, the best practices of industry baked into the design. And we have a defensible position if there were ever a problem.
So it doesn't save you from having like a poor product market fit or bad design or anything like that.
No, it doesn't.
But from a safety, best practices, and I want to say solid engineering, but sounds like safety and best practices perspectives,
yes,
and maybe quality as well. Like that's where standards are your friend.
Mm-hmm, mm-hmm. Yeah, make no mistake. I'm not suggesting that it's going to help you product market fit, and maybe you really want to do that up front. But if you're going to do nothing more, at least do a risk assessment.
Yeah.
Just understand what are you facing, right? You may aim your development in a direction that is more likely to become something that you will be able to sell in the future.
Yeah, makes a lot of sense to me.
See, that's why we created balanced engineering.
Yeah, that's a beautiful thing. So I think that's probably a good spot to end on. I mean, that's...
Yep, looks like it. Yep.
Perfect note.
Well, yes, exactly. So, it's interesting. We discussed a number of dimensions, but at the end it comes back to purpose. It comes down to purpose, right? And thank you for helping us. Thank you for letting me explain what the purpose is.
Absolutely. So on the way out, I always ask people if there's anything they want to plug. I mean, you just mentioned balanced engineering, so I'm sure that's the thing. But is there like a formal message you want to state, like at the very end?
Pittsburgh in the next 5 to 10 years might be probably one of the most exciting places to be. Not only to build cool technology, not only to build successful products, but to really build sustainable businesses. I'm super excited and thrilled to be here.
Awesome. Alex, thanks for coming on.
Welcome.
Thanks for joining us today. If you made it this far, chances are you'll like other episodes too. Collaborative with Spencer Krause is available on YouTube, Spotify, Apple Podcasts, Google Podcasts, Pocket Casts, and Radio Public. Subscribe today to get notified when the latest episodes release and support the channel. Collaborative with Spencer Krause is sponsored by SKA Custom Robots and Machines. If you're in the market for robotics contract engineering services, please consider hiring SKA Custom Robots and Machines. They sponsor this podcast and they solve some of the toughest engineering challenges in the world. SKA Custom Robots and Machines can be found at ska.solutions. Thanks again, and see you on the next one.